Geometry nodes can be daunting to many, including myself, but whenever I fully grasp something, I feel the need to tell someone about it, thus this video. In this tutorial, I will help you understand how to manipulate points on a plane per any still or moving texture and create something akin to this sand particle system I created in Geometry Nodes for the background of the Small Gods book review post. Okay, we're going to start with scattering and moving particles. The first thing that we need to do, of course, is go to the Geometry Nodes workspace. I haven't really worked with Geometry Nodes enough to have a custom workspace, so this works for now. I don't always use this evaluation database thing on the left, but I still keep it because sometimes I need to know how big or small my values are. So this setup works for now. And this is where the geometry node tree is gonna go. Well, now I don't have an object, so let's add an object. I'm going to add a plane because that's the easiest way to demonstrate what you're trying to explain. A plane kind of creates that 2D screen. And then I'm going to go to top view with 7. Also, I don't have a number pad. I like to adjust the settings over here from edit preferences, and I go to inputs, emulate numpad. That way I get to use my normal numbers to change my view. But if you find that a little bit annoying because it does remove some parts of the shortcuts that you have previously with the normal numbers on top of your keyboard, then I would just encourage you to buy a numpad that you can use to add more shortcuts to your Blender setup. Okay, now that we have added the plane, we have the modifiers tab finally. And this is where you can add the geometry nodes modifier or the geometry nodes node tree. When you add a modifier, you can find the geometry nodes over here and you can add it from here. But I like to make it a shorter process and just add a new geometry nodes over here. So it adds the modifier and then it also adds the geometry nodes here or the node tree that you have over here. Because if you add a modifier from here, you're going to have to either add a new geometry nodes or select the one that you already have. I just do it over here. It takes 2 steps out of my workflow. And then if you want to rename it, you can. I'm just going to call it Twisty Sand Particles. And it changes over here. Now we have something called Twisty Sand Particles. And then we're going to scatter points or convert this into points rather than a mesh. You can of course apply the same node tree that I'm creating right now on this mesh or on the vertices of this mesh and create the same shape without using the points. The only difference is going to be not distributing points on the faces of this mesh. But what I want to do is create a sand particle system. And so I need points for that. As you can see over here, we have the data for the positions of the 4 points that we have on the plane. Because we have right now 4 vertices, 4 edges, and 1 face. And if you see over here, you can see that the 0 point is at -1 on the x-axis, -1 on the y-axis, and 0 on the z-axis. And because this is a 1 unit or 1 meter plane, then if you go -1 on the x-axis, that's to the left, and then -1 on the y-axis, that's down 1 point, then this is the 0 point. And if I look at the 1 point, it's at 1 on the x-axis on the positive, and then -1, so that's going down on the y-axis. So that's point number 1. But you can look it up in a different way if you go to Edit, Preferences, and then you go to the interface and turn on Developer Extras. I think this is what you need to do in order to see the indices. Before you turn on the Developer Extras, you can just go to the viewport overlays and check if you have the indices. If you don't, you're going to have to turn on the Developers Extra. And if you turn on the vertices, you're going to see the index of each point. So this is the 0 and this is the 1. And then the 2 is at -1 on the x-axis, 1 on the y-axis, and 0, because none of them go above the center point. So if I go to front view again, or top view, And then to check that everything is working properly, I can just do a set position from the geometry. And then select the indices that I want. So the way I can select it is by hitting Shift A to add, or you can just add from here. You can do a search for index, and then I can check if it's equal to a specific index, and that is going to go into the selection. So this way, when I offset, I am sure that I'm offsetting the index that I'm choosing. So right now, it's comparing whether the index is at 0, and indices are always integers, so you cannot use float for this. The 0 index, if I shift it like this and I move it on the z-axis, it's going to move. And if I choose 1 instead, then 1 is going to move. If I choose 2, 3, and then above that, there's absolutely nothing because we don't have data for that. And if you do it in programming, the first thing that it's going to give you is an error, and it's going to tell you that array is out of bound because the array here has only 4 items, and with arrays, it always starts with the index 0 and ends with the length of the array minus 1. So if you want the last element in an array, you always go with the length of the array that you have. So if you go to the vertices over here, you can see it's 4. So I know for sure that the last index is 3. Okay, now that we already know where the indices are, I like to hide them because in this tutorial, we're looking at textures rather than indices or anything specific. So we're going to leave set position, but we're going to set the position of points rather than the geometry's vertices. I pull a line from here and I choose distribute points on faces. And then we're going to leave it at random. And then we are going to input the points into the geometry for set position. And you're going to see that they're randomly positioned on the faces of this plane, which is right now just one face. Okay, so I made a mistake before when I said it was a 1 meter by 1 meter plane. It's actually 2 by 2. And technically that makes sense because it goes from 0 to 1 on each of the sides. So when it comes to distribute points on faces, it distributes per square meter. So for every 1 square meter, we get 10 points. But because it's random, you're not going to find that we have only 10 in each square or in each square meter, but it's going to be collectively 10 multiplied by that number for every square meter. So if I go down to 1, then we get 4 because we get 1 for every square meter. It's multiplying. And you can definitely just choose integer for this just to make sure that you're going up by integers. But if you don't want to do that, you can definitely just scroll over here and you can just increase the density over here and it's going to be a float number. And then if we go to 2, then we're going to get 8 because 2 per square meter. And so the 10 over here is going to be 40. That's just to not confuse you. I'm 100% sure that none of you is counting and you're literally doing it visually because that's how I think geometry nodes is intended to be used. But I like to know these things just to make sure that I understand how many points I actually have and why my system is suddenly lagging. And you can change the seed of your randomness. This is basically a number that points to the way this randomness is going to work or the pattern of this randomness. Because if you think that the computer is doing things randomly, then you're mistaken. It's definitely a pattern, or it's definitely a collection of numbers that you can change using the seed. And if you look up the code train, I think on YouTube, you can see that he has a book filled with random numbers. He can explain it better than I can, but if you change the seed, you're basically changing that order of the randomness. And this is also something that you do visually. So if you go one by one, you can choose the one that you like the most when it comes to randomness or noise, because those two things have a seed. We're going to stick with 0. I never really change the random seed because I can't see things changing visually with things like geometry nodes and distributing points on faces. And as we saw before, if I shift this a bit, once changing the offset, everything is going to move on that axis by the amount that you specified. But you're not really moving each point. And for us to move each point, we need to give it a texture that it grabs its information from. So the offset is going to be based on a texture that decides how much that point moves on any of the axes. And we're going to move it on the z-axis mainly, but I'm going to also show you how you can add a little bit of randomness on both of the other axes that you have. And before we do anything else, I want to show you how you can change the point size that you have over here, because once you have too many points, it's going to start to melt into each other. So you can do that with set point radius. I didn't want to do this later on because it might start to get confusing once the tree gets bigger. And then you can input this over here, and this is how you can change those points. For now, we're going to leave it at 0.05 because that's fine. We can see it. And we'll only be moving the points on the z-axis. So how can we vary the point's height to create something interesting? I mentioned before in the textures and materials video, even in the short, you can see it in a glimpse if you like. Everything that is white goes up and everything that is black goes down. So if we have a texture that has whites in it, then it's kind of like we're adding to that point's position, if we add it to the offset, a value of 1. So we're still working with numbers, but we're looking at it as an image. And because I want to focus on the z-axis alone, then I'm going to have to add a combine XYZ. Combine XYZ allows us to input things into each axis separately instead of moving it over here manually, because I want to do things using a texture. So I can do a combine XYZ, I can do whatever I want to the separate axes, and then everything is going to flow into that vector by keeping the X and Y at 0. Okay, let's start with a gradient texture, because that's what we're going to use to create the twist animation. So if you have Node Wrangler, you can hit Control-Shift and click on this to bring up the viewer so you can see the gradient texture like we do in shader nodes. And I have to give it a point of reference when it comes to geometry. So I have to give it the plane as the geometry. And you can just close the eye if you want to hide the plane and see the tree or the final geometry that you have, and then turn it on to see the values that we're working on here. And I want to choose a radial gradient texture. And then I want to add a color ramp just to make the colors sharper, make it a constant, and input that into the viewer so we can see it. Immediately, things just start breaking and it's not showing us the correct gradient. And the reason for that is because we don't have enough points or enough vertices. So what I like to do is either subdivide the mesh that I have, or I can change this into a grid that I can add from the geometry nodes menu. So with Shift-A, I can search for grid. And this way, instead of the geometry I have already, it can just be a placeholder that I'm putting a geometry node tree on. And I can input this into the mesh instead. And I can also input it into the viewer over here. This is going to be a 1 unit mesh because it's 1 meter by 1 meter. You can definitely make it 2. That's up to you. This is simply a size. And even now it's still broken because we don't have enough vertices. So if I go up to 4, you can start seeing it a little bit better. It's moving in a circle as I move the color ramp. I'm going to make this 100. And now you can see it moving around the plane. We'll go back to linear for now. I just wanted to show you that if the mesh is not subdivided enough, it's not going to work because we don't have enough vertices for the points to move smoothly. That's why the shader wasn't smooth at first. So now I am going to show you how you can repeat a texture. If you want to understand every math node that the geometry nodes tree have or the shader nodes have, you can definitely go to this video or to this playlist and understand it all from a mathematics point of view, but I'm going to try to explain it visually over here with the little animations that I'm going to add. So if you want to repeat a pattern, what you need to do is scale that pattern or multiply it to how many you want them, how many ones you want to have of that pattern, and then you're going to use one of the math functions that turn it into a pattern. It's going to become clearer once we add those math nodes. So if I do a fraction, or technically I can't do that, I can just do math node, and I choose vector math because I'm working with color here. Even though you can definitely use regular math rather than vector math, just linear, because the colors are only black to white, but because you can add more colors, then it has to be outputted as a vector. So we're going to work with vectors. And if you change this math function to one of these that creates a repeating pattern to either fraction or modulo, because those are the two ones that I use the most, I don't really use the other ones that repeat, then you can repeat this pattern into multiple ones based on how much you scale that pattern. So I'm going to explain it on fraction because that's what I used. So what fraction is doing is basically removing whole numbers and taking that repeating pattern that goes from point, let's say 0, 1 to 9, 9. If we go from point 1 to point 9, then that pattern is going to repeat despite the whole numbers that you have. So if we go at 0.1 to 0.9, and then if I do 1.1 to 1.9, the fraction is still the same. It's repeating. And that basically repeats the colors as well, because the colors are going from 0 to 1. And if you think about it from a vector point of view, then it's going to go from 0 to 1 per each color, which are RGB. So the viewer over here is showing us the X values, the Y values, and the Z values, because we're using a vector. And for us to be able to see that, we need to add more values to this gradient texture, because right now we only have one that is going from 0 to 1 once, but we need it to go multiple times, and we can do that by scaling this texture or technically multiplying it. Scale is just an easier way of multiplying a vector by a scalar or by a float value, rather than using multiply and then just multiplying all of these by the same value. It's just easier to use scale. That's it. And if I input this over here, right now it's just multiplying by 1, but if I multiply it by 2, then we get 2 of that texture. We're going from 0 to 1, and then again from 0 to 1. And then if I do 3, then we're going 3 times, and so on and so forth. If I take this over here, duplicate it with Shift D, and I input it into this, and I go 10, then it's going to repeat 10 times. Because what I'm doing is removing those whole numbers and just taking the decimals that are repeating. So if I go 4, these are 4 repeating patterns. And if I go with a float, then I can also repeat it smoother, but the last one is not going to complete the cycle of the repetition, because it's only a fraction to number 14, let's say from 13.6. So we only have kind of half the point of that, or 2/3 of the point of that repeating pattern. So that's why I like to input an integer in here, so I can have a full pattern each time. And you can do this with any texture, basically. So if I go to a linear texture, then I'm getting this as well. But because the starting value for the linear gradient texture is all zeros, then you're going to have to shift this entire thing. And if I use spherical, for instance, then that same thing happens. And if I add a scale to the texture itself, and I use the position over here, then I can scale the entire thing, because I'm scaling the texture right now rather than the points inside of the texture. The same goes with linear, but again, you have to shift it. Okay, let me explain this better on the linear. So if I just look at the gradient on its own, what we see is a lot of zeros, and you can actually see the values over here. They're all zeros until we reach a point which is technically the half point. That is about, what, 5,000? Yeah, because we have 10,000 vertices right now. So at the 5,000 mark, we start to have a 0.01, and that's when we're starting to go through the gradient to a 1. By subtracting that value on the x-axis by -1, then I'm shifting every point by 1 to the left side. And now if I go up to 5,000, we can see that it's become a 1. And that's the 5,000 mark, and now it's 1 because we shifted the entire thing, and now we have lots of 1s over here. So to rectify that, we need to scale it by 0.5. And then instead of subtracting by 1, we can just subtract by 0.5. Because if I look at the scale on its own, the zeros over here are multiplied by 0.5. That doesn't really change anything. But the values over here are multiplied by 0.5, making the 1 go up to 0.5 rather than 1. If I remove the multiplication or the scale, then you can see that it goes up to 1. What I need to do is move it only to 0.5 over here. So when I subtract only half of that, so to move only half of the plane to the left, I can get the 1 back. Okay, let's go back to the fraction and then increase that number to, let's say, 4, and also change this to radial because that's what we need. And with radial, we don't really need to scale it or to subtract it. Just the normal position is fine. You don't even need to add that position right now. Position is implied. It's actually what we're manipulating just now with scale and multiply, because the textures use it to know how its values are set, because we don't really need to change much for the gradient texture itself. And this is where things come in handy over here when you start to want to understand why certain values are working in a certain way. It just shows you the data of the mesh that you have. And now to move the points per this texture, I can just input this fraction into the z, and I can immediately see that we're moving according to that texture's value, or white and black values. And if I look at it from the side view, we can actually see that it goes from 0 to 1. It never goes to -1 because I don't really have negative values. And as you increase this, you're going to see changes in how this moves, because the points are random and not every point lies on that black point, or not every point lies on the white point. And because we have more white than black, then you're going to see more points going up than there are down at the 0 point. And if you change the seed, of course, you're going to change how those points are distributed on this mesh. And so the texture will also apply to those points differently, because again, it depends on where those points are in terms of that texture. Okay, now let's twist that pattern. So I'm going to go back to viewing the original mesh so we can actually see the pattern. And go to top view again with 7. So if I want to twist a texture, I should look at it from a numbers point of view. Even when it comes to visualizing it, you just have to kind of think about blacks and whites in terms of points from 0 to 1, or numbers from 0 to 1. We need a texture that goes from a very large value in the center, so it twists more, to a very low value on the edges. And that is something that we can get from the spherical gradient texture, because it goes from 1 in the center to a 0 on the edges. And so it will have more rotation in the center than on the edges. And you can definitely do a multitude of textures or shapes based on what you're using to multiply, or what textures you're using to manipulate another texture. And because I want to rotate those points around the center point, I'm going to pull from the color and use rotate vector, because we want to rotate the positions of those textures using this texture. And I'm going to use the position over here. This is going to be a static value, so we need to add something in front of this gradient texture, like an add vector math. Also, because the rotation is not gonna accept a color, it needs a vector. So you can definitely just transfer that into a vector rather than a color. And now if I move it on the z-axis, we can actually see it rotating. And some weird rotation happen if you do the other axes, which we don't really need. We just need the z-axis because that's what we're looking at right now. We're going from 1 in the center, and you can see the edges over here where things just stop rotating, but rather just moving around the circle, because that's what the texture is. And because the gradient texture just stops over here. And so these areas are being multiplied by a 0 rather than a 1 or a 0.5 over here. And to rectify that, you can, like we did before, scale the entire gradient texture based on the position. And if I look at this value over here right now, we can see that the rotation or the twisting goes to the end. The spherical texture is applied to the radial texture and twisting it, but to increase that twist, we need to multiply. But we don't need to multiply the entire texture, we need to multiply the values inside of that texture. Because when we scaled the entire texture by using the position, we kind of started from 0.5 in the center, and we need to shift that to go above the 0.5. So we go multiply. The rotate vector, if you're wondering, doesn't take degrees when you input something into it. So a rotation of 1 is about 57 degrees. If you change it manually, it's going to be in degrees, but if you input something into it, it immediately turns into radians. So if you're wondering why the 1 is creating such harsh rotation, it's because it's radians. And if you want to play with how it's going to look, you can definitely multiply on the y-axis and the x-axis. That way you can create some really fun textures. But what we're doing right now is just twisting. And the bigger the values on the z-axis, the more twisting you're going to get. Well, let's see how this affected the position of these points. We can't really see much when it comes to how these points are offsetting on the z-axis, so we need to increase the density. So I can go up to 10,000. This is where it differs for every person, depending on how strong your computer is. You can see how things are looking in terms of point. And this is when we should set the point radius. See how it's much easier to do it first, and then you can just change the values. 2.02, let's say, so we can actually see how the rotation is happening. And I have to shift the view a little bit just because top view isn't really showing me much. It's really giving me this gradient look where these are the lowest points, and then whatever goes over here just goes up until it gets to this area over here, like so. These are the highest points because they're white, and then we go back to the lowest points over here, which if we shift it a little bit, we can actually see it. So if you want to animate this, you can easily just add a combine XYZ because we only want to add nodes to the z-axis. You can definitely animate this over here with drivers by just clicking on this alone. But I like to do it this way because we do have a node for frames, not this one. Well, scene time is what it's called because I didn't really pull from here. If you do pull from here, you can search through the nodes themselves. You can just add this, but because I just did Shift A and searched, you can only search for the nodes themselves. So I can just do scene time. And now I can use the frames into the Z. And now if I hit space to animate, you can actually see it like so. But I need to make this slower, so I'm going to multiply by fraction. Let's say 0.1 to make it slower, and voila, we're animating the twist. I want to show you how you can manipulate this further. If you move these over here and add a value between the factor and this Z offset, that is going to change how those colors look. So right now we're going from 0 to 1 perfectly, but we need to change that a bit. We want to go from 0, so the floor, if we want to add the floor at the 0, 0 point on the z-axis, then I want to go from 0 to 0.5. I want to go up to 1. I want it to be shorter. So you can do map range, and I can just do a float. I don't really care about it being a vector because I'm only going through the z, but because I pulled it from here, it thought it was a vector that I'm trying to map its values from a certain range to another. So this is my favorite node. It's similar to the color ramp. I've always used mapping in coding because it just allows me to change, let's say, a rotation that goes from 0 to 360 degrees into something linear that goes from 0 to the width of a canvas. So we know that the values that are coming out of fraction, because they're grayscale values, so I'm going to go from 0 to 1. So whatever value is 0, I want it to stay at 0. And then the maximum, instead of going to 1, I want to map it up to 0.5. And if I actually view this right now, instead of what I have, fraction, you can see that it goes now to 0.5 rather than 1. When I had it before, it was 1. Now I can go down to 0.5. And if I also want to raise this from the floor area, I can just increase it a little bit so it's not as black. So whatever values are 0, they're going to start from 0.06, and then it's going to map each of the values in between, kind of dividing by the amount of points that we have and dividing the range of values that we have to the new range. And so now we have different steps in terms of the amount that we get between one number to another. So if I have 10 numbers that goes from 0 to 10 and I want to map them to 0 to 5, then I want to compress the 10 values into the 5. And now if I look at it from the set position or from the group output, I can just remove the viewer, and now you can see that it's shorter. And if I make this 2.2, then we're closer to the floor because now we're reaching the 0.2 line. And to take it even further and make it even more interesting, we can randomize those points. So to randomize, I can just Shift A, search for random value, and I can add this value that we have with random values and input that into the z-axis. Right now it's very messy because we're going from 0 to 1. But let's say I want to go to 0.2. You can also multiply by a percentage if that makes more sense to you. And definitely you can change the seed for that however you like. I like to add it because adding is not as big of a value. If I look at it like so, it's too uniform and it's very clean. But if I add this to it, then it's a little messier. And I can make it a very small value, so the change isn't that big, but it's still making a bit of a change. In my project, instead of doing it over here with regular math, I did it over here with vectors. So I can also shift or offset the x and y a little bit. So we can choose the vector over here, and we can add using a vector math rather than regular math, just so we can offset on all of the axes separately. So I can do 0.01 on these two, and then I can do 0.005 on the x and y. And it gives it a little bit of an interest rather than it being too uniform. So if I go, if I change this offset to the uniform one, you can see the difference between this and this. This just shifted things a little bit. You can also increase this even more. And because we're going from 0 to 1, even on the X and Y axes, what we're doing is moving the X and Y, or shifting them only diagonally like so, going to the positive side. So if I want it to shift to the left and right, or top and bottom of the center point, then I'm going to have to do a negative value over here. And you can see it if I go up to 1 with this one. You can see that it's shifting too much diagonally to the right and top. So if I go to -1 over here, then it's centered, because we're saying give it a random value, or add a random value from -1 to 1. But we need it to be a smaller number, so we can just do -0.1 to 1. That is too much of a shift that we're not seeing the pattern anymore. Even if I look at the animation, sure, we can still see some of it, but the majority of it we cannot really see. So I can even go smaller than that, -0.01 to 0.01. We can still see the animation better right now. And if you want to animate the strength of the twist, then you can definitely animate the Z value on the multiply. So you can use this to also, by duplicating it, if I can do that, and then applying the animation to this as well. So you can definitely rely on the frames to twist the entire thing, but also increasing that twist as the frames move. This will also give you a different look. But I'm going to keep the twist static, and I'm going to just, the twist number static, and I'm going to just go with animating the twist itself. But after doing this, well, it looks nice from certain angles. It didn't look as nice in the angle I wanted behind the book and in the foreground as well, because the twist didn't really look like it was twisting. So I just needed something that goes up and down randomly. So what I did is, instead of having this gradient texture and this entire repeating pattern, I had a noise texture. So let's frame this entire thing. By hitting Shift P, you can frame this, and if you hit F2, then you can rename it. So I'm going to say main pattern. And I'm going to just remove these two values from here and create a different pattern. So what I want is a noise texture. If I want to look at it, view it on the grid mesh, and then I add a color ramp. And if I remove the vector over here, you can see that it's a regular noise texture. I just added this twisting vector. So you can definitely just put this in a frame as well. Shift P and then F2 to rename it, twisting pattern. So this exact same one, we just connect to the noise texture. And then if I look at this, I can increase the blacks and whites. And if I turn this off, nothing is really happening because I haven't really connected it. So I can just connect it to the value over here, and we start seeing something. And the animation is still going. We can also decrease the number over here, 0.005. We can also decrease it over here because the entire thing is just a little bit much. And I didn't need to do the repeating pattern with a scale and fraction, but you can definitely do that if you want. I'm just going to use this original one, and you can change the scale on this to make it slightly larger. We can either smooth it with the color ramp, or you can smooth it with this one over here. And you can definitely decrease the radius for the points to 0.1, and now you have a fun noise twisting texture. And instead of animating the twist over here, I animated the W when I used the 4D texture. So I just used and you can remove it from the frame by hitting Option or Alt P. And I use this on the W over here. But again, we have to multiply by 0.05, let's say, so to make it slower, even 0.01. And this is what I did for the Small Gods Sand Particles animation. And even instead of multiplying, I did a map range for the frames. And I looked at the end frame and plotted over here, so 250. And then 1 over here for the start frame, because I want to map the frame range to whatever values I want for the W. So if I want it to go from 1 to, let's say, 5, then it's going to go through the frame range that I have, 1 to 250, and it's going to divide the 1 to 5 onto that. So it's going to smooth it down to fit that frame range. Then you can play around with the map range for the height of the offset for the points. And then you can also play with the randomness for these points. If you want to loop the animation, you can see that there's a jump when it hits the 250 mark over here to go back to the 1. That's because the noise texture isn't looping. And you can do that if you look up this video. It's one of my favorites when it comes to looping a noise texture, and you can create a group node for that, so you can use it over and over again in every project you have if you add it as an asset. For now, we only have one thing left, and that is exporting the animation. So what I did is export this into an alembic, but because we only have points, that doesn't really export. So what I need to do is change this into a mesh that I can export. And I can do points to vertices. And now I have vertices that I can export as an alembic, because alembics need a mesh to export, and it will bake the animation into a sequence. And when you import that back, you're gonna get a bunch of vertices that are moving. And then you can add another geometry nodes to it. Let's see if I can do it in the same file. So if I add geometry nodes, I add a new one, I can grab this mesh, and I can do mesh to points, and I can choose the vertices, and then I can choose the size of it. Let me make this bigger so it's much easier to see, and I get the points back. But I also went a step further and did instances on points. And the reason for that is because the points don't really render in an animation perfectly. It just gives me a glitch. I had to render that multiple times. Even if you see that it renders as an image, it doesn't work in an animation. It just glitches over and over again. So I have to instance on points, and I use icospheres or spheres. I think I used spheres in that one, but I think for sand particles, it makes more sense to use icospheres because they're not uniform. And then you can change the size. I like to change the size before I put this into the instances point, because it always lags when they're too much and too big. And now I have these on each of the vertices. I can make them even smaller. And it's very easy to export something as an alembic, because I didn't really show that. I would just remove this geometry node. And if you hit M on the keyboard, when you select something, you can just remove it. So now we can actually see the points, because before we had the vertices and we don't have the overlays, so we can't really see much. So I can just mute this with M. And if you want to export it, let's bring back the overlay so we can see that it's selected. I made a mistake muting this and then exporting as an alembic, or showing you to export as an alembic. It shouldn't be muted. The mesh, which are the vertices, is what's going to allow you to export as an alembic. Otherwise, you're gonna get an empty thing whenever you want to import that alembic. So you mute it if you just want to continue editing it, and you unmute when you want to export as an alembic. File, export as alembic, and you can choose wherever you want. The only thing that I make sure to select is selection only, and then choose wherever you want to save this, and then export alembic. And once you have that, you can go to File, Import Alembic, and you pretty much have just a mesh that you can add any modifiers to. And I add the geometry nodes modifier that I just showed you with this. The other way you can export this is by marking your geometry nodes as an asset. So you can right click on your geometry nodes, mark as an asset, and then you can add this file that you marked this geometry nodes in as an asset to your Blender assets folder, which you can find over here. Edit, Preferences, and then File Paths. And these are your asset libraries. So I do have just one folder that I add everything to that is called Blender Assets. I don't think I have anything in main assets, but mine is definitely Blender Assets. I add everything I have when it comes to the asset library in here. So any file that I mark assets in, I just add inside of the Blender Assets folder, and it just applies to any Blender file that I open. And I can just drag and drop the geometry nodes asset into this. This is another way that you can export your animation. So you're basically exporting the node tree rather than the animation itself using an alembic. So you have more control over what you can change in that geometry nodes tree. And you can also add values to your group input. So if I duplicate this group input, but because we don't have anything connected to it, we can just put it over here. I can, for instance, add this as an input. And when you mark this as an asset, now you have these values to change, and you can name them from here if you hit N, or if you click this little arrow over here, but N will bring it up. You can change this type of value. I will keep it as a float because that's what it is. You can add a description to it. You can add defaults to it, what the default value you think is the most fitting for this animation, because the majority of people have a default of 1 to 250 when it comes to frame range. I think that maybe 0.01 is perfect for that when it comes to speed. And then you can add a minimum and a maximum, so they cannot go above when they're scrubbing like this with the mouse, if I'm doing it like so. And you can rename it as well. So if I double click on this one, I can do speed factor. And that will make you remember later on that this is the speed factor. So changing it will change how fast this moves. You can also do twist speed. You can specify what speed you're talking about in terms of your animation. And you can add more to that as you go. And then if you hit N, you can just remove those settings. And finally, you can also add a material. It doesn't matter if you add it before this or after this, because this is muted anyways, but I'm gonna add it before. You can set material, and this is what I did, and then input it into the point, because again, it doesn't matter. You can just input it over here, but then you've removed this from the tree altogether. I don't like to remove it in case I just want to unmute it like so. And then select a material. I don't really have a material for this mesh yet, so I'm going to add a new one. And then I'm gonna call it sand. And let's choose it over here. So now we've set the material. If I go to shading, let's actually go to material, remove the overlays. I can grab the object info, and I can input random. It's not going to do anything because technically this is my material for the actual sand particles after I added the icospheres. This is going to work and it's going to make it random, but I'm going to show you how you can preview it for points. You can just do point info, and random is going to give you the same as what the object info random is going to give you. And I'm going to add a color ramp, change those colors to something that resembles sand. And you can definitely add more colors. And that's pretty much it. Just make sure that when you add instances on your points, then you're going to have to use the random. But here it's not going to work because we're looking at the points. You can also color it with position, but because we moved on the z-axis, I want to separate that. So right now, this is what position is going to look like for each point. I can use a separate x, y, z and only use the z-axis. With these colors, you're not going to see it that well, so you can just plot this into base color directly, and you can see the blacks are always going to be down, and whatever value we reached in the end for the top is going to be on the top. So we technically don't have any whites because we only have a range that goes from 0 to 0.2, and there's also a randomness over here. It's even more varied than that. Yeah, I hope you enjoyed this video. It took a while to film, and it's definitely going to take a while to edit, to add in all of the animations that are hopefully going to help you with how you understand this geometry note setup. And please check the links down below for any of the videos that I shared because they really have great information that can add to your geometry notes. Yeah, that's pretty much it. I'll talk to you soon. Bye.